Hi again, everyone. Dr. Tom McNamara back for our course in Prep for College Math. I wanted to get into the mechanics of long division, since it is an algorithm we will need to use for quite a few of our problems here. And I want to look at this example, and I want to try to understand why the setup for long division works the way it does. Okay, so if we think about what the division process really means, right? We talked about it in a previous video, how it was like breaking something up into groups. So 15 divided by 3 is 5, because we take our 15 items and we count 3, 3, 3, 3, 3. We have 5 groups of 3. Alternatively, we could think about something that is 15 units long, and we take a 3-inch ruler, and we want to know how many times we need to place that 3-inch ruler until we completely measure the 15-unit object. So here we're divided by 8. So we're imagining we have an 8-inch ruler, and we want to know how many times we need to lay that 8-inch ruler side to side until we can get way over here, 2,147. Now I could do this counting by 8s. I could go 8, 16, 24, 32, 40. We'd be here a while, but I could do it. Okay? It's much easier at the beginning to take bigger jumps. Don't take jumps of 8. Take jumps of 80. Or better yet, take jumps of 800. You might say, hey, Dr. Mack, if taking bigger jumps is better, why not take jumps of 8,000? Well, what we'll want to do is, we don't want to go over 2147. So if we start by taking a jump of 8,000, we've overshot our target. But I can take a couple jumps of 800. Okay? If I make a jump of 800, that would take me here. If I take a second jump of 800, that would take me here to 1,600. If I take a third jump of 800, that would take me to 2,400, so that's too much. Okay, we only want 2 jumps of 800. Okay, I'm going to put that right here. How many, this is in the hundreds place, right? Thousands place. This would be talking about jumps of 8,000. Okay, why is it 8,000? Well, because my divisor is 8. Okay, we don't want any jumps of 8,000, that goes too far. Jumps of 800, we can do 2 of them. Now I want you to look at this gap. Okay, this gap is 547. Take 2147, subtract 1,600, you get 547. Okay, so your 2 jumps of 800 give you 1,600. You subtract 547, right? You do have to borrow here. Take this 2, cash it in. For 10 over here, you'd have 11 minus 6, which is 5. 547. Okay. Now, we're going to try and cover not the entire 2147, but we're going to try and cover the gap. And now, we're in the tens place. We're not talking about jumps of 800 anymore, we're talking about jumps of 80. So let me think about this here. Jumps of 80. 80, 160, 240, 320, 400, 480. If I do one more, I'll be at 560. So 7 jumps is too much, but 6 jumps is just right. 1, 2, 3, 4, 5, 6. You might say, well, Dr. Mack, it's not just right, there's still a gap. Okay, we'll deal with that in just a sec. So each of these jumps represents 80. So I get to 80, 160, 240, 320, 400, 480. If I did another jump, oh, I should do one more jump. Oh no, sorry. No, one more jump gets me to 560, which overshoots the 547, okay? So this is the number of jumps I want. 1, 2, 3, 4, 5, 6. I'll put my 6 here, 6 jumps of 10 times 8. My tens place times my divisor. Jumps of 80. And we saw here I can do 6 of them. 6, and remember this 6 times 80 is 480. And then we do a subtraction. 7 take away 0 is 7. Borrow 14. 67. Okay? And then 4 minus 4 is 0. So I've got a gap of 67 left over. Right? This is why I couldn't have another jump of 80 because I would have gone over. So I'm focusing now on this gap that's left over. 0 to 67. And I'm talking about jumps of 8. How many jumps of 8 can I take? Getting as close as possible to 67 without going over. 8, 16, 24, 32, 40, 48, 56, 64. That's as close as I can go. Another one would take me to 72. So I can do 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. Each of these jumps represents 8. It gets me all the way to 64. The remaining gap is 3. Okay? So we saw 8 jumps covers 64 units of the 67, 3 left over. Okay? So my quotient is 268 from this operation. My remainder is 3. Okay? So, you might remember your long division here taught to you like this. You don't look at the whole thing. You just look at the first digit. But the way to think about it is, this is the thousands place. Okay? If you've taken jumps of 8,000, you're going to overshoot that 2,000, so you can't do any thousands. Now you're talking about 2,100 with jumps of 800. And the good news is, remember, when you're working with stuff that has zeros at the end, okay, you can kind of ignore the zeros. Just focus on this. How many times does 8 go into 21? Well, 1 copy of 8 would be 8, 2 copies of 8 would be 16, 3 copies would be 24, that's too much, so we just go with the 2 copies. Okay, this is in the hundreds place, so it doesn't really stand for 16, it stands for 1600, because remember we temporarily ignored those 2 zeros. Okay, so I multiply that, we get this, bring all that down because we're subtracting. And why are we subtracting? Well, we're focusing on the gap that we have to cover. We're trying to get to 2147. 2 jumps of 800 gets us to 1600. Our gap is 547. So now we try to cover that gap with jumps of 80. How do we know it's jumps of 80? Well, we're in the tens place, and our divisor is 8. 8 times 10 is 80. Okay? So I'm not saying you need to draw these number lines every time. The reason I'm doing this is to get us to understand why this setup is the way it is. Remember, one of the points of this class is make math make sense. Okay, we should understand why the methods that we use work. Okay? And my goal in presenting it this way is to hopefully get you to understand where all this business comes from. Okay, we're trying to basically measure out this distance with our 8-inch ruler. We could do it, just keep on counting by 8s. But it's much better to start by counting by 800s, and then count by 80, and then count by 8. You keep on refining it, you keep on dealing with a smaller and smaller gap each time until you can't do anymore. And you know you can't do anymore if the gap that you're left with is smaller than your divisor, in this case 8. Okay, so this is why the the long division algorithm works the way it does.